Okay, good morning and good afternoon to everyone. Thank you for joining our Smart Rail Innovation Program 2022 to 2025 Autonomous Rail Crossing event. I'm here with my colleagues Morgan and a few other QTRIC staff who are working behind the scenes to ensure this event goes smoothly. Before we start, I'd like to do the land acknowledgement. So I'm currently located in Hamilton, Ontario, and in the spirit of respect, reciprocity, and truth, we honor and acknowledge the lands which constitute the present-day city of Hamilton, situated upon the traditional territories of the Erie, Neutral, Huron-Wendat, Haudenosaunee, and Mississauga. This land is covered by the District 1 Spoon Wampum Belt Covenant, which was an agreement between the Haudenosaunee and Anishinaabeg to share and care for the resources around the Great Lakes. We further acknowledge that this land is covered by the Between the Lakes Purchase of 1792 between the Crown and the Mississaugas of the Credit First Nation. Today, the city of Hamilton is home to many Indigenous people from across Turtle Island in North America, and we recognize that we must do more to learn about the rich history of this land so that we can better understand our roles as residents, neighbors, partners, and caretakers. QTRIC's actions go beyond the land acknowledgement. We have a gender and racial diversity policy in place that encourages the hiring of diverse voices. We support Indigenous-led businesses when possible with contracts to support economic growth within and among our Indigenous communities. We support ongoing research and federal investment in the exploration, investigation, and analysis of missing and murdered Indigenous persons and the mass and unmarked graves of children that went missing in the residential school system in Canada. We strive to make Canada a greener place and support climate change initiatives, including through innovation and support better mobility in Indigenous communities. Next slide, please. Before moving forward, I'd just like to do some housekeeping. I think most people are familiar with Zoom, but there's the unmute and the start video. So please keep yourself with your videos on and yourselves muted. Next slide. This event is being recorded. There's a chat feature at the bottom, and you can click on the participants to see who's registered today. And as we go forward, I would ask that your questions be placed in the chat, not the Q&A module. Just put them in the chat so we can have them saved for the future. Next slide. Okay, so I'd like to call the meeting to order now. Next slide. And before going further, I'd like to do a little bit of a roll call, just so everyone knows who's present today. So I won't read everyone, but I'll give you a few seconds to skim over the list. We have a very diverse group, cross-section of industry, transit operators, academia, nonprofits, other associations, consulting services, industry suppliers, and those interested in getting involved more. Next slide, please. Our agenda today will be, we've done the welcoming. I'll spend a few minutes here filling you in on where we've been, where we'd like to go. We'll introduce our speakers. We'll have a discussion, breakout sessions at the end of our speakers, where we're going to break groups into pre-assigned spots where you can have more informal discussion, answering 2 questions. The one question will be, how can the Government of Canada support innovation in the field of autonomous bus rail communications at rail crossings? And the second question would be, what might CUTRIC's role be in leading autonomous rail crossing analysis and feasibility modeling? And then we'll bring everyone back, and our moderator will facilitate the discussions. We'll have comments from each of the sessions read to the entire audience, and then we'll facilitate group questions at the end before closing off. So the questions you should put in the chat feature as they come up. And then we will adjourn. Next slide. So the Smart Rail program that CUTRIC started in 2020 for 2022 to 2025, we've identified autonomous rail crossings and bus vehicle communications at grade as an important element to connect transit operations and to avoid collisions. Next slide. Today we're here to talk about autonomous rail crossings. Next slide. So we had a consultation session a few years ago where these 6 areas were covered as topics that we would like to discuss with the industry as a whole, and that's what these sessions are. So what you've got 1 to 6. 1 was hydrogen rail feasibility, battery electric bus integration with rail stations, passenger data analysis, and rail to bus transit scheduling integration, autonomous rail crossings, which is today, high frequency rail versus high speed rail policy focus in Canada, which is upcoming early in 2024, and cybersecurity and rail operations in Canada will be covered as well. And more on that a little later. Next slide. A little bit of a history of our program. So back in 2020, there was a study that was produced on rail innovation in Canada, where it featured the top 10 technology areas for passenger and freight rail. It was a report. We then moved, CUTRIC then moved to the Zero Emission Transit Fund, which was announced by the Government of Canada in 2021 to address climate change and sustainability in the transportation sector. In 2021, we launched our inaugural Smart Rail Transit Conference. And from that came this program that we're here today, the Smart Rail Innovation Program. And then in 2022, CUTRIC was selected as the Zero Emission Transit National Planning Service by Infrastructure Canada to help transit agencies electrify their bus fleets. Next slide. So why develop autonomous rail crossings? So, I mean, we have a long history of rail in Canada and around the world, of course, but there's been a number of incidents and accidents in the past, which can be very tragic. So developing autonomous rail crossings, in our opinion, and I think you'll hear from the speakers today, they can optimize rail bus operations at crossings. They can enhance vehicle to infrastructure implementation and support vehicle to everything autonomous vehicle communications. In urban and suburban areas, autonomous rail crossings help expand route planning options as we approach autonomous vehicle implementation. It helps accelerate safety and collision reduction benefits provided by 5G and artificial intelligence. It'll inform community safety parameters around rail crossings through new technology applications, and it'll assist in optimizing transit scheduling and passenger satisfaction levels. Next slide, please. A bit of stats. There's a lot more stats, but we only need to cover these. So Canada's rail system is about 43,000 kilometers. CN and CP own 50% of the total tracks, which amounts to about 21,500 kilometers. Other entities own a different percentage of them, and passenger rail owns 18%. Next slide. Just a graph here, a picture of a graph of how an autonomous rail crossing could interact with streets. And I think you'll see some interesting presentations coming up after me of how this could work in an urban environment. Next slide. So to do this right, you need automation, and that's a loaded word, and our speakers will address that much more later. But CUTRIC has launched CUTRIC launched an electric light shuttle commercialization project a couple of years ago with some local transit agencies with the objective of providing autonomous shuttle service. And the reason why I mentioned that here is because that's an integrated feature that goes with autonomous rail crossings. If we can go to the next slide. Basically, both systems overlap in many aspects, having many of the same characteristics, technologies, features, and challenges. By collaborating on commercialization projects and pilot projects, collectively, industry can help inform regulators and the broader industry on the best paths to move forward, utilizing data collection and analyses to help inform and develop potential common protocols and standards, without which progress would be very slow individually, technologies would be varied, and successes will not be many. This can be compared to the auto industry and its electrification strategies, where each company wants to establish its own charging networks and standards, and only recently have most of them decided to adopt the Tesla charger network for their own vehicles due to their distribution in the market. So by de facto, the industry has sort of settled on Tesla chargers becoming the sort of industry standard among most automakers in the current environment, saving them billions of dollars and accelerating EV adoption by eliminating one of the greatest concerns consumers have, that being range anxiety in charging. I mentioned that analysis because through commercialization projects, where you can overlap autonomous shuttling and rail crossings, there are synergies, and you can help develop common standards that would work for centralized locations in urban environments. Next slide, please. Of course, there are grade crossing regulations and there are other regulations, but the regulations are focused on enhancing the safety of grade crossings, which are under federal jurisdiction. And then the roles and responsibilities of railway companies and road authorities, they intersect, and so it makes it a very complicated process to go through. And that's why we're doing these sessions, to try to get all the players in the same room to see if we can advance the agendas. Next slide, please. So the Canadian Rail Crossing and Smart Vehicle Project, Vehicle Pilot Project. So the technology, in our opinion, has evolved and brings outstanding capabilities for optimizing rail operations. The advantage is to bring those specific applications to grade crossings. Recent worldwide projects have demonstrated the value of V2X and V2I smart vehicle communications, and as mentioned, with 5G and artificial intelligence, which is in play now. And CUTRIC members and partners can describe their experiences, provide lessons, and suggest next steps in these sessions that we coordinate. Next slide. And so with that, I've done with the introductions, and what I'd like to do now is I'd like to, well, this is a slide of our speakers today. We'll have our MC, Marcin, and then Marco and David, and they'll each be introduced separately at different times. But for now, I'd like to turn it over to Marcin Taraskevich. How was that? Sorry. So Marcin is with HDR, and we'd like to thank our colleagues at HDR for providing support, and you'll see and hear more about them in the next little bit. They are working with us in the background on this to produce this event. So I'd like to turn it over to Marcin, but before With that, I'd like to just give a little bit of background on Marcin. Marcin has over 30 years of professional experience in transit engineering, project management, design, testing, commissioning, integration, operation, and maintenance. His extensive portfolio of projects includes new car procurement and overhaul of light rail, heavy rail, and commuter rail cars with major clients both in North America and abroad. Marcin is HDR's Rail and Transit Vehicle Technology Lead and specializes in the assessment and implementation of zero-emission technologies for rail transportation. He's a bachelor degree in aerospace engineering from the University of Michigan and MBA from DePaul University, and is registered as a professional engineer in Maryland, New York, and Virginia. He's also a graduate of the Leadership APTA program. So with that, I'd like to move things over to Marcin, and thank you, Marcin, for taking over as being our MC and moderator.
Well, thanks very much, Vince. That's a great introduction. Really appreciate Kutrik's efforts put together for such an interesting discussion. I appreciate everyone who joined us as well for I think what's going to be a very good discussion about a very important topic in the world of railroading and in road transport as well. So what's interesting, what's so important about rail crossings, grade crossings? Well, you've got two busy modes of transportation. You've got road transport, that carries millions of cars across Canada, US every day. And you've got railroads that are getting busier as the demand for passenger service and freight service increases. And rail crossings is where roads and rail meet. And so it's a point of let's face it, competition where the road traffic and the rail traffic competes for space. Rail traffic has obviously the right of way. When a train is coming, the gates go down and the road traffic gets stopped. But that that sort of point where, or that time where the rail traffic and road traffic meets is getting more and more frequent, especially in the urban areas where we see a lot of car traffic and we see a lot of rail traffic. So as traffic increases in both modes of transportation, the potential for conflict increases as well. And that's whenever you have any type of conflict that happens, a collision, it's typically something that can result in the loss of life, certainly injuries, loss of property, damage to property, service disruptions for both the road and the rail. So it's really critical for us to look at this topic and to see how we can quite frankly eliminate all these rail crossing, grade crossing incidents. There's been a lot of work that has gone into this over the last several decades. It's been there's been a lot done in terms of grade crossings designed on the roadside, where they effectively try to have markings in advance of grade crossing, lane separation, gates, signage, warning lights, and so on and so forth. On the rail side as well. We've made advances in rail warning devices and how they're triggered by the rail traffic. On my end of things as well, even with the vehicles, there's been a lot of work that has gone into designing rail vehicles with the potential of rail crossing collisions in mind. So there's a fair amount of safety features built into modern rail vehicles to ensure that in the case of a collision at a road crossing, that you minimize the damage, minimize potential for injuries and fatalities. So we've made a lot of progress, and I should not forget also a lot of the outreach that's been done. I'm based here in the States. We have Operation Lifesaver here in the States, which is an outreach program that seeks to educate everyone who lives near the railroad on how rail crossings work and things to do and not to do around rail crossings, all with the aim of keeping people safe and ensuring that they understand the hazards involved at rail crossings. But still there's a lot of room to improve, right? So I looked up the statistics for last year, for 2022. There were 160 crossing accidents in 2022 in Canada, which is an 18% increase from 2021, likely due to increase in road and rail traffic. About 10% of those, unfortunately, result in fatalities. When you move down to the U.S., that number is around 2,200. So 2,200 road, rail grade crossing collisions in 2022, with 272 of those resulting in fatalities and another 819 resulting in injuries. So it's a very large number, despite the number of rail crossings that we have throughout the U.S. of Canada. I think it still shows us that there's quite a bit of room for improvement. So I think this is why this topic is so important for us to discuss, and so important for us to look at other ways that we could improve the road rail interface. I think we have modern technology and some great tools available today that could be applied to this. And the two speakers that we have today will discuss approaches that we can take with the goal of eliminating these grade crossing accidents while also maximizing the traffic on both road and rail through these rail crossings. So minimize interference and maximize safety. So with that, I will introduce first speaker. It's Marco Kernke, who has more than 25 years of experience in the rail business on a global scale. He started at Deutsche Wagenbau, which was later taken over by Bombardier Transportation, leading the independent and certified testing facilities for railways. Afterwards, he was responsible for global standardization and the headquarter management engineering for locomotives and production optimization. In 2012, he was appointed to product management of fully automated and driverless transport systems, which is, by the way, where I started in Bombardier as well, years ago. He led all research development, including innovative autonomous people movers. Finally, he was overall responsible for global technology innovation and research. In recent years, he founded his own company, Kernke Consulting, with service and project delivery for airports, battery technology, and autonomous systems. Additionally, he is co-founder and CEO of IM Rail, innovative monorail technology, developing a new and total turnkey monorail system. He was also responsible for Ricardo Rail building and leading business activities in Canada, and is now working as principal consultant. Further on, he is president of the International Monorail Association. So with that, I will turn it over to Marco, and he'll be our first presenter today.
Thanks a lot for the kind introduction, and thanks a lot, Gutrick, for having the opportunity speaking here about a topic where I believe Canada has a great experience in the area of fully automated trains. And typically, I prefer to talk about automatization rather than autonomous. But I believe David Beach will bring some lights into the definition of this wording as well a little bit later on then as well. As we have both the history from Kingston and automatization, I believe in formerly centuries, we had to do the stop, look, listen, beware of trains, just a sign so we can see, and maybe have to put the ear on the rails to hear whether a train is approaching or not. But these days, everything is and can be automatized, specifically in the railway industry. And I want to talk more about what is being done in the industry for automatization in the past decades. We all know the projects here in Canada and Vancouver, and even the Scarborough line with the fully automated and driverless trains. But we even can go back in the 72 for the people mover, where we had already as well fully automated systems. So on the next slide, I just want to give a broad overview. When we as rail engineers talk about fully automated and driverless systems, it's well defined, it's well regulated. You can see on the top left chart there, we have the grade of automatization between 0 and 4, with being 4 the highest one, where there's no need of any attendance on the vehicle. Typically, we move this function in automatized electronic way and still have people in the so-called operational control center. So everything leads together there, where the main supervision will be done both by humans, but as well by the automatic systems. The automatic systems is as well heavily standardized and controlled in norms and codes, where we do have the automatic train control, the automatic train supervision, the automatic train operation, and the automatic train protection. So we have different layers. They go more and more denser, whereas the only and the highest safety function is the automatic train protection. So in principle, when this automatic train protection detects any faults coming either out of the automatic train operation, the supervision or train control, it will go in saying it's not a safe mode anymore, and it will brake automatically or even will not run. Let's say doors are open or some issues with the brake or anything else than there. And this is since decades. We have more recently the European norms, the 5126, 128, 129. I think the 126 is now transferred into 726 with a more calculated way of safety, as we have already proven that the automatic trains are way more safe than any human can be. And this is calculated in so-called safety integrity levels, where we have from 1 to 4 different numbers there based on the hazard. Hazard analysis typically has to be conducted associated with the risk. And this can be calculated with the severity and likelihood into real numbers. So the highest safety integrity level of 4 means that we have 10 to the power of -9 probability of any events will not cause any death or catastrophic failure of the system. So it's a very established process and system on the automatization of rail systems, typically or specifically in the fully automated driverless systems then. Coming on the next page, I want to bring an even higher view on the topic, on more like planning of transit systems, with having in mind fully automated and driverless systems. The picture you can see a little bit, my heart is with monorails. You see a heavy monorail system in Sao Paulo. That's a 7-car train carrying 1,000 people, elevated up to 15 meters. The goals are the same for all transit system, having a safe system, an efficient system, and a high reliable system. And different transit modes have different ways of how to achieve these 3 goals. One can be to be fully automated and driverless. As I mentioned, if you eliminate the human factor, you automatically will become much more safe. But as well, the segregation of the guideway helps a lot in less interaction. That helps a lot in terms of having easier reaching shorter headways and more capacity. And that means as well that you can build your transit system either elevated or underground, not to have any interference with other traffic. So this helps a lot, and this is one of the goals. This is a little bit in contradiction to what we try to achieve, which is as well to have safer level crossings. Level crossings on the next page have been in the past really with a gatekeeper post. We have as well manual crank handles for the bars that run up and down there. We have various signs, we have flagmans, lights and bells. We have different ways of gates going to both directions, not to the road traffic only, but as well to the rail traffic. We have barrier arms. So this is various solution across the globe, how typically crossing look like, whether they are just manual operated with the human, or whether they are connecting with a signaling system, with an interlocking system, or standalone, various functions there. But we have as well a new and innovative modern way of looking at crossings. On the next slide, where we can see improved systems that are either already implemented or in research. A very interesting innovation and research project from the SNCF, the French federal operator there, is having a project called Smart Crossing, where an interaction from wayside to vehicles is being investigated and implemented in some of the examples there. So the driver having like warning or any kind of information that the level crossing will be occupied in the next time. But as well, they do both ways. So not only the infrastructure to vehicle communication, but as well the vehicle to infrastructure. So both ways they are investigating how it can be done in a safe way. The obviously challenge is do we have all vehicles crossing as well the intelligence to do this communication or not, on the one hand. Second, how can we make it safe to have the communication in a way to fit into the automatization programs of the rail way of thinking? We have as well already some radar scanners. I put an example from Germany, from Honeyway. So they scan the area. They know if there are obstacles already at the crossings. They send signals to both the barriers or to any kind of other signaling elements that finally can lead as well to communication to a train driver or other station. We have as well other sensors like from Mermec, LODs, so laser obstacle detection. We have as well radar system, LiDAR system, like SICK is providing LiDARs to the automotive industry. So obstacle detection is upcoming here. It's possible to detect there. Again, big question for me is how safe do we need to make them? How safe can we make them in terms of fitting into the safety integrity level in the way of automatization of rail overall? On the next page, some of the example I want to show that I've seen and even writing by myself. Here you see that's an autonomous shuttle, so more like a small bus, a road vehicle on a fully segregated guideway. Not fully segregated, as you can see, a rail crossing both for cars and for passengers, whereas it functions in the same way as you can imagine any kind of switch. So it has a central control system that knows when the red lights are turned on and the barriers are down. And only in this case, the vehicle is allowed to cross this area there. The system is in place since 1999, so really more than 2 decades ago, and now it's running in the 3rd generation. It's close to Rotterdam in the Netherlands. Another example on the next page is more for freight. You may have heard about Rio Tinto, the AutoHaul system. It's obviously in rural area with big truckloads of iron ore there, transferred over a couple of 100 kilometers there, where they have fully automated their operation as well. It's a grade of automation 4. So obviously they do have as well crossings there, where they do have a similar system with the central control and supervising as well the rail crossings there. So this is in service operation and in place, and I guess a good spot to look at as well what we can leverage from there. On the next page, we see a slightly similar approach more from the streetcars or trams, where they try to as well replace the driver by sensors by mainly as well obstacle detection system. Again, the usual sensors like radar, LiDAR, and camera system, or even stereo camera systems for various weather conditions, for various other areas there. So there was a project in Potsdam for a fully autonomous tram in place. Actually, where they started is a little bit more easy in the depot area, because it's a more controlled area, but they have gained a lot of information about how can it be safe to do level crossings as well with the tram, at least helping the driver, but the goal is to eliminate the driver at all for an automated tram. On the next page, we see the principal complexity of automation we do have, and this includes the rail crossing, where we have on the right side a completely uncontrolled environment. So maybe pedestrians, maybe animals, maybe any weird functions happen at an area that interacts then with our transit system that we are trying to implement in terms of speed, the intersections, the access, and the behavior. So coming more to the left on either semi-controlled or fully controlled environment, it is an easier way of doing the automatization. So obviously interaction with the environment is key. How easy or how difficult the process, the regulatory authorization and certification of the system, and the technology implementation of an automatization process will happen. Finally, on, I guess, my last slide, we have a great project from the European Horizon 2022, or formerly Shift to Rail Joint Undertaking project. It's already completed system where they did as well as supervisory of railway crossings there in actually 3 different ways. They had obstacle detection on the vehicle. They had as well obstacle detection system on wayside, but as well they had with a drone an in-air supervisory system, all connected, which they call a cloud system, making smart decision then within some control units there, including radar systems, leading these decision then to the kind of the cloud, or I kind of really call it central control here in this case, but at least give information to the entire system, whether the railway crossing is free to operate, whether there's any kind of obstacle either on tracks or somewhere on the rail crossing, and whether it's safe to move ahead or whether the train has to be stopped earlier. We all know trains are heavy, and as well, depending on the speed, they at least have several hundred meters of brake distance there. So it's not possible just for a human driver to see in front of the railway crossing, oh, there's an obstacle, I brake. That's typically always too late. So this is what this project is about, to have a very early warning and early signaling and communication that the system knows it is not safe to drive any further. So with this, I guess the very last slide, I want to conclude that it can make sense on having smarter ways of railway crossing, whether we want to call them automatization, if we have a more automatized rail system anyway in place, or whether we call them autonomous, meaning definitely more smarter in a way to have definitely a more safer way, detecting any kind of obstacles there, having higher degree of efficiency there, that we can run higher capacity on both sides, and definitely have a higher reliable system, as meeting as well the 3 main goals of rails here there. With this, thank you so much, and I would like to hand over back to Marcin.
Thanks very much, Margot. It was a great presentation. Really a lot of good points, a lot of good ideas there. So just I want to remind everybody, as Vince said before, we'll do a Q&A session after our breakout session that's coming up here after our next speaker. And we'll address any questions you have about the presentations then. So now I'll move on and introduce our second speaker. David has been building critical systems with artificial intelligence and advanced sensors for over 20 years. As a graduate student at the University of Toronto Institute for Aerospace Studies, he studied computer vision and control, with a later focus on information dynamics and evolution algorithms. He worked for over a decade in the space industry at Naptech Design Group in Canada, Ontario, where he helped to put 2 mission-critical machine vision systems in orbit. He currently works in the Research and Technology Group at Thales, Canada, bringing computer vision and AI into safety-critical urban rail applications to build the next generation of safe and performant rail signaling and control products. So with that, David, please take it away.
Okay. Thank you, Marcin. Thank you very much. And thank you to everyone for joining today. So just at a very high level, what I'm going to talk about is the work that we're doing, sort of innovative work in what we call generally autonomous rail. So I'm going to speak. A couple of people prior to me, Marcin and Marco, have both mentioned the kind of road rail interface and the road side of it. What I'm going to talk about is from the rail perspective. But as we go through, I'll point out that obviously always to keep in mind that this is really about road and rail. So when we talk about crossings, we're talking about critical parts of the rail infrastructure that interface with the road network. So there are always directions that can be done on the road side. I'm not going to spend a lot of time talking about that, but I will go into what technology is, what's the current state of the technology, and maybe expand a little bit on the types of things that we've been doing that are similar to what Marco was just talking about. So next slide. So just a quick overview of Thales in the urban rail signaling part of Thales. For those who aren't familiar, Thales Urban Rail Signaling, headquartered in Toronto here. It's about 2,200 employees around the world. And the main offerings are the communication-based train control system called CellTrak, which is, to relate back to what Marco was saying, is providing automated signaling and train control from GOA 1, from the grade of automation 1, all the way up to automation 4, driverless systems. And is also another offering is the route control systems, which is called LockTrack for interlocking, as well as the various services and analytics and digital services that accompany these. So we're present in more than 15 countries in many big capital cities, largest cities around the world. And in fact, the Toronto is recognized as the global competency center for urban rail. And it's also where the bulk of the innovation work is done on the team that I'm with, which is the research and technology team. So we'll go to the next slide, please. So I'm just showing here a couple of innovation successes we've had in the last few years around the world. And just starting on the left, this is the left and the center are sort of related to our work in autonomous onboard autonomy. So on the left, it's showing an image of the Flushing trains in New York, where we have been testing and running what's called the next generation positioning. It's I'll talk a bit in a moment about the different sensors, but essentially it's what we call autonomy ready positioning upgrade. So it's taking the existing positioning system and upgrading it to be used to use autonomy sensors or perception sensors generally. In the center is some work that we did that we demonstrated in 2021 using a number of different sensors you can see on a vehicle on the Metrolinx network. And it was showcasing the ability to do many of the things that Marco was showing, detecting obstacles, reading signals, things that can help the driver, and as well as other types of things like high integrity positioning, remote management, remote monitoring, and also even mapping of infrastructure. So these are all things that are possible with this, with what we generally refer to as autonomy or perception sensors. And on the right, it's just a little bit of I mentioned kind of data analytics and services. These are the sorts of things that you can do once you have the volume of sensing information that's coming from the train, inertial information, visual information, 3D information of the guideway. You can start to do much more advanced anomaly detection, sort of reliability monitoring, and even and energy optimization. So the next slide. So I think I've mentioned autonomy a number of times. It's probably a good point to sort of describe what we mean by autonomy, because it is used in a number of different ways. And so we contrast between, as I mentioned, we already have automated systems. So we contrast between automated systems and autonomous systems. So in an automated system, you have a set category, or sorry, a set catalog of movements that are being executed in constrained environments, and they're sort of everything is in many ways defined in terms of constrained environment ahead of time. But of course, we know in the real world, there's a lot of situations where you're not in that constrained environment. And so in many situations, when the operating environment or the system ends up in this sort of unexpected environment, this can happen if a driverless system loses position, and there's no way to recover. Normally in most systems, you typically would have to send a driver to drive that vehicle to the next safe point. And it can happen in many other situations where you may want to just help out, for example, help out a driver. So drivers can get, we may want to be able to provide warnings when signals are being approached and so on. So these are all actions or behaviors that an autonomous system can do. And it does it because we define autonomy as the ability to make or support human-like decisions. So what we look to do is we look to take the current sensors that are on vehicles nowadays, which are things, they're blind sensors like wheel sensors and RFID location sensors and so on. And we want to remove those and replace them with what we call autonomy or perception sensors. So these are sensors that can give the vehicle itself a view of the world around it, like radars, lidars, cameras. And we put the computing power to do vehicle-borne perception and intelligent decision-making. So what this does is it gives the vehicle the ability to see the world around it and to make some decisions and to help human drivers and operators to make decisions. But in the meantime, when doing this, you also, there's a number of other benefits that come along with it. So by removing some of this infrastructure and some of these sensors from the vehicle and out of the track bed, you can now do similar things, but with less infrastructure. It allows you to be flexible in the way you can deploy things. You can deploy them vehicle by vehicle quicker, which means that migrations and upgrades are quicker too. And then in addition, and this is sort of listed a number of them at the bottom, it enables a number of new functions and services, and even sort of what we call value-added or add-on services like mapping, collision avoidance, which is a very common function that people see a lot even in cars. But you can even do anomaly detection, as I mentioned. And then what I've been talking about up to this point is an onboard platform, which is, and we call this platform TAP. We've been working on it in the context of a vehicle-borne platform. But a lot of these functions, what we think of as autonomy, are really things that can be done on the wayside as well. And you can see in the bottom right is a video that shows, in fact, a level crossing here in Toronto that's being monitored by, as part of a demonstration by one of the SMEs that we partner with in the city. And you can see it's being monitored to detect when there's vehicles in the level crossing, and you'll see in a moment as the train goes through it can monitor, as Marco was pointing out, it can monitor the occupancy status of the level crossing. But as I'll get to in a moment, there's a lot of other things that can be done with this type of system at the crossings. So next slide, please. So that's the first pillar of a lot of the innovative work we do, vehicle autonomy and autonomous systems in general. The second pillar that's very important for these types of systems is what we call advanced networks. And in particular, we're looking at high performance networks. And we look a lot into 5G technology. And we look especially into, for critical applications, private 5G. So these are networks that can provide you time-sensitive networking and guarantees about how long things are going to take to transmit. But what's really important is that it also, by going to private, and we can and do work with public 5G, but the advantages of private 5G for safety critical systems is that it allows you to get access and configuration of the network that's suitable for specific application needs. So these are, you can now look at services like high performance localization and optimizing the network without having to worry about proprietary lockdown, or without having to be limited to the types of configurations that are suitable for mass market communication services. You can really focus in on the things that you need for your specific safety critical application. And the next slide. And then the last pillar that we build on is the amalgamation of all this type of information into dashboards and other web accessible tools and visualization tools. So this can include interactive maps. This is something that we looked at when we were working on the WinterTech project with on the Metrolinx line. And as well as I mentioned, energy optimization, asset tracking, and maintenance tracking, such as using the vehicle sensors to look for things like vegetation growth and ballast, and just looking at the state of the network and communicating that back to back office locations. So all of these pillars are what generally support a lot of the innovative work that we do, or the innovation that we do in autonomous rail and rail in general. And they're all relevant when we start to talk about level crossings. So if you can jump to the next slide. So how do these pieces fit together when we're talking about level crossings? Well, I mentioned before the difference between an automated and an autonomous system. And so an autonomous system, as I said, it can make human-like decisions, and it targets to manage these unexpected conditions or things that may be not possible with a strictly constrained automation policy or system. So one way I like to explain it is, if you think of at a level crossing, there's a number of things that can happen that can lead to a potentially dangerous incident. So there have been stories in the news, I'm sure some of us may have seen them, where, for example, a vehicle was parked in the level crossings, and even though the arms went down, there's no way to know that level crossing was occupied. But in these situations, there are, as Marco was saying, there's technology. This is what we refer to when we say an autonomous crossing. You can think of it as if there's a human being standing there. So that's the goal of an autonomous system, is that you could think of it as being a human that's standing at the level crossing and can see that something has gone wrong, that the automation is not able to catch. So it's adding this extra level of intelligence into the level crossing. So when you have that, then you can also, with the communication systems that I was talking about, you can relay this information to other vehicles, including the train or even other vehicles in the road network. and effectively give the driver of the train a beyond line of sight awareness, or any other drivers, beyond line of sight awareness of what's happening at the level crossing. Next slide. So what I want to do is just take a couple of slides just to talk about some of the use cases, again, from the rail side. And the big one, I think, is this, what I just referred to as this beyond line of sight driver advisory. So Marco mentioned another technique or another system that uses drones. What these autonomous or smart level crossings are doing is they're giving the level crossing some intelligence and some perception to notify incoming or vehicles that are approaching the level crossing, or the drivers that, for example, you might want to tell them something's happened before the gates are down, or gates went down when there was someone in the level crossing. So this is looking at a specific region of interest with different sensing technologies. I'll get to that in a moment, and just providing an indication that can be useful to a driver approaching who may want to, for example, slow down, even though maybe there's ample time to brake, enough time to slow down and just make sure there's nothing happening in the crossing ahead. So the idea here is that it's sort of a discrete example of the drone that Marco was showing, where you're protecting these critical road rail interface areas. And in many cases, you can even, especially in an urban context, you can leverage the existing power and infrastructure that's there to install these systems. So next slide. And then the other use case that's relevant for the rail side is the monitoring of operation and maintenance information that's relevant for operations and maintenance. So in this context, for example, having these sensors at the level crossing allow you to confirm the correct operation of the gates, the arms, the lights, all of the systems that are involved in the automated part of the level crossing. But you can also use these types of systems either permanently installed or even in a portable capacity from one crossing to another, to monitor the time it takes for the train to go through the crossing, how long are the arms down, and so on, which is of interest when it comes to supporting decisions for capital expenditures. So if you find that you've got congestion and traffic is building up and so on, the arms are down too long, they don't need to be down that long. These are all things that can be sort of refined once you have the ability to essentially what we used to do by just putting a human sitting at the crossing. So now we replace that human, in this case, with an intelligent perception system. Another use case that's relevant, not so much for urban transit, but more for freight or supply chain applications, is to be able to use these systems to monitor and recognize the vehicles that are in a train consist. So by being able to say, this train has these cars in it, and these are the correct cars, you can send that back to a back office to be logged and checked to make sure that there's not an incorrect configuration of trains being sent well before they reach their destination and the error is discovered. And then the others two at the bottom, I think, are really important as well. One of them I mentioned already, which is looking at the traffic patterns, but broadly you can look at how cars are piling up or other road traffic is piling up. How many of them are turning around? How many of them are waiting too long? And then a really important one at the bottom, I didn't leave the least for the last. This is looking at how often do we have near miss incidents, or how often do people jump under the arms or try to bypass the safety measures. So this is something that without these types of systems, you really would not have this information, but it's critical to understand what can be done to make these crossings safer. And the next slide. So this is just kind of the last slide I have, where I want to just go into a little bit what's the state of the technology and sort of the sort of technical and sort of system level challenges and the status of where we are right now. So the first two items on this, I think I'll talk a little bit about. I talked a little about the data management and especially high performance networks and communication. Of course, for these types of systems, we usually target to do a lot of this processing at the point where the raw data is generated. Nonetheless, in many cases, there may be a desire to send video data and send even real-time monitoring data. So one thing that we find with all of these systems, as they become more complex, obviously the communication needs increase. But what we see is the high performance 5G and even future generation of networks have the ability to give us these functions and these capabilities that we need. With regards to the sensors and the processors, I mentioned a few sensors. Obviously, there's a lot of advanced sensor technology that's available right now. The key ones for perception, especially at the level crossing, are the cameras, radars, and LiDARs. And what's important to understand is that when you're talking about a system that has to be safety critical and has to achieve these levels of safety integrity that Marco described, each sensor technology has strengths and weaknesses. And in the context of perception, the sensors are complementary in that in many cases, when one of them doesn't work as well, the other one does. So in the traditional trade-off, where you have to trade off between performance and safety, what we find is that the systems almost by necessity need to be multi-sensor. So one sensor technology is very difficult to use in a safety critical system, especially with these perception sensors. So, and then when you have multiple sensors that have to be processed, you need high performance processing. In the last couple of years, we've seen quite an advancement in the sensor technology that's available and in the processing. And really now that building block is there. So we have the sensors that can detect with the resolution and the accuracy and so on that are needed, and the processors are available now with the power to do this. What we've also had to overcome in this space, everyone's had to overcome, is safety certification. And the first step is safety certification of complex algorithms, newer, more advanced algorithms. And I think in many cases, the industry has found ways to work within the standards or to in any case certify these types of complex algorithms. Obviously, there's always still work to do. The algorithms get more complex, but I think one of the big focuses right now is on the perception side, where you have to use AI. There you get into safety certification where there's still a lot of open questions. And in many cases, the way it's handled is AI is treated like an untrusted sensor. So this is still an open question. There's a lot of work happening. And the final one that I have, sort of technical challenges and directions, is more of a system level view. And that is, how do you make decisions at the system level? How do you decide if the system detects something? How do you decide how to use that information? And this is, it may not seem like it's challenging, but it does become a really important aspect, because it can be dependent on the specific context in which you're, the specific place or system in which you're deploying it. And it can also even be dependent on the specific instantaneous or context of the moment. So there's some really challenging questions to understand about how you use this, how you make decisions, and even how much information do you display to the driver? What information do you display to the driver? What information would be relayed to other vehicles on the road, and so on. And so I think that's my last slide. I hope I didn't go too much over time. I just wanted to wrap up by saying, as I was oops, the screen just locked, of course. As I was saying, the technical and technological building blocks are there. For the most part, we've seen the sensors and the processors have kind of caught up to what are the general requirements in this space. Of course, rail has some harsher requirements in some sense than automotive. There's no doubt. Stopping distances and the fact that we already have driverless systems running in all weather conditions. But for the most part, to do many of these use cases, the technological building blocks are there. We also see around the world many jurisdictions that are investing heavily in this. I know Marco talked about a couple. There's in the EU. There's a very strong focus in a lot of the technology development and R&D in these areas. And as was mentioned as well, we can be a leader in this. We've got the expertise. We have a number of companies and SMEs and bigger companies that work in this space that are capable to contribute and new technology and export that technology around the world. So we can be a leader in the development and deployment of this innovative transit technology. And that's it. That's everything. Thank you very much, everyone.
Thanks very much, David. That was great. It was a great presentation. So now we've heard our two presentations for the day. So we will now be broken up into discussion groups where we're going to have a question posed to us and have a discussion about the question that's been posed and try to formulate an answer as a group as to what our takeaways are from this discussion. So now I think I will turn it over to Morgan, who will assign us to different breakout rooms.
Yes, before I go ahead and do that, I'll just pass it over to Vince so we can, and click to the next slide so we can look at the questions so everyone is prepared on what to speak about. Perfect.
So yes, so thank you to our speakers. And so our next process will be the breakout rooms. Everyone's been pre-assigned. So it's by industry, sector, and category. And we're just looking to have a more intimate conversation surrounding these two questions. How can the Government of Canada support innovations in the field of autonomous bus rail communications at rail crossings? And the next question is, what might be CUTRIC's role in leading autonomous rail crossing analysis and feasibility modeling based on our experience with what we've done with other transit agencies in our zero emission bus projects? So with that, Morgan, I think telegraph us out to the different breakout rooms. And we'll see you all in 20 minutes.
Okay, well, I think everyone is back now. And so we had some great discussions. I know I had a great discussion in my group. So let's talk to the folks who were the leads in the discussions, each individual group, and have folks report out. Let's go in order. Who's the first on the list? Somebody help me out here. It was, I think, it was the agency group. Is that correct?
That's right. Government, transit agencies. We'll start with group one.
Yep. So let's start with group one, the agency group then. What were your takeaways and what were your sort of major points from the two questions that were asked?
So we'll just ask Vince and Saloni.
Yeah, Saloni, do you want to speak?
Sure. I can go ahead, and then Vince, feel free to jump in
Sure.
at any point. So I think I think one of the unanimous takeaways was particularly related to how the Government of Canada can support was having better guidelines. There just seems to be a lack of guidelines in terms of autonomous bus rail communications at rail crossings. So that's something that there was there was some discussion around there. And then we actually got a US perspective as well, where there one of the comments was that oftentimes like the government always ends up reacting to at a time where there'll be a major accident. And when you're considering these guidelines, you have to take safety. Safety is a big factor. And oftentimes the government ends up taking a conservative approach with respect to that. So there's often a reaction when there's a major accident. So then there'll be guidelines developed as opposed to being proactive in developing these guidelines to help other agencies in designing their system. And then the second, I guess, related to the second question in terms of what QTRIC can do, one of the suggestions was, well, QTRIC can probably take a more proactive approach in working with the government in developing these guidelines so that agencies can better equip their rail systems. And another piece was about partnering with universities and academia, which QTRIC is already doing. But this is something where there's a lot of research that's happening, and oftentimes each different group or organization, so universities or different municipalities or agencies, are sort of doing their own thing as opposed to a much more consolidated approach, and that's where QTRIC could help in managing that, so that there's a much more defined approach in research, or even implementing the research forward in this space. Vince, if there's anything I missed, feel free to.
That's fine. Yep. That's thank you.
All right, great. Thanks. This was really good stuff. So let's move on to group number 2 and see what answers, what takeaways group number 2 came away with.
Here I can run that back for you, Martin. So for group 2, the consulting group, similar to the first group, safety was mentioned. Of course, needing a set of frameworks and guidelines to ensure that this can be deployed across a vast network was discussed. A couple of the other things that we discussed were funding, and that the government can support by funding these sorts of trials of new innovative technology, because if it falls on the transit agencies themselves, the cost can run up quite quickly. So some kind of grants, we discussed having grants, and then Marcin having you in our group was very helpful. And we learned about in the US how for your zero emissions work, there are specific targeted strategic grants that you can apply for. And a similar sort of grant structure here would help in terms of alignment and making sure that all developments for autonomous crossings are cohesive and they sort of overlap towards one sort of end goal would be very beneficial, and that's a good place for the government to step in. Aside from that, we talked about, I mean, communication as well. You mentioned was an important thing. By basically, the government can just step in by telling the industry that this is a new space that we're trying to get into, and just having a clear line of dialogue with industry would be helpful in making sure that these innovative approaches can be implemented sooner rather than later. And then for question number 2, now granted we sort of went over on question number 1, so we didn't have as much time as we would have liked for question number 2. But for question number 2, we did discuss in terms of the modeling itself, rather than having a one-size-fits-all approach, to create a few different models that can be used for the dense urban centers, the sort of rural remote areas, and different types of crossing modeling that can be used. And then when you have these different models that interact with different levels of traffic and different level of pedestrians, you can sort of apply each one of those to different corridors to determine which model would work best for different corridors' needs. And then the more you roll out these approaches, the more you'll be able to see how they sort of work, and that will lead to your set of standardized guidelines, frameworks, to make it easier to have these rolled out down the line.
All right, thanks very much, CJ. That was great. Let's move on to group 3.
Hi, so with the first question and what the government can do, there was sort of centered, our group centered around 3 areas. I think I could state that. The first was really the requirements of outlining what the government wants to achieve. It was noted the technology is available, so focusing in on tests, on a test case and outlining what they want to achieve with that test case, pre-qualifying bidders, and then actually having those bidders write the specifications for the test. It was also noted that it would be good if the government could fund test tracks or test locations for this, so that really the technology could be segregated and used in order to see how the tests respond and in order to sort of profile the technology. A third case was, it was noted that these technologies are highly cellular and data intensive. So certainly continuing to fund 3G, 4G, 5G network expansion across Canada was another area that was suggested for focus for the government. In terms of how QTRIC could assist, it really focused in on the fact that there's a need to have a value proposition written, the benefits case analysis for these technologies, and so that the government has a better understanding of what to invest in. So helping to gather the information to create that value proposition was seen as an area that QTRIC could focus in on. Another area that was mentioned that's a little bit offside, and I think would apply both to QTRIC and to the government, was the university funding for the future, future people who are going to be working in this area is lacking. And so practical training for engineers and for research staff in terms of how this technology works and how they can use this technology and maintain this technology and test this technology was also seen as something that's very important.
Okay.
Thanks, and please jump in if I missed anything from the group.
Thanks very much, Whitney. Appreciate your insight. And I think we have a 4th group. Is that correct?
No.
We don't. Okay, just the 3
today.
groups. All right, great. So, in just hearing what everybody answered, I did see some common themes there. We talked about funding, certainly. In both funding the projects themselves and funding additional research into this topic. So that's always important. I know there was an example I used in my breakout group is, in the US, we had 2 recent sort of efforts in the railroad space. One was the deployment of the Positive Train Control PTC, which ended up being a fairly expensive undertaking. And at the end of the day, the government to step in and release some funds through grants and others and other funding mechanisms to allow folks to deploy this fairly critical safety system. Otherwise, it just there were a lot of railroads that just wouldn't have the funds available to do this. And right now I'm working in zero emissions as well in the States. And it's a similar thing. The federal government and some state governments as well, most prominently California, have made funding available now for agencies who want to come in and either procure new zero emissions equipment or convert existing equipment to zero emissions. Really, because the cost of this stuff is very large, and there's a lot of rail operators. The big folks, the CPs, CNs of this world, probably can't afford it. But the fact is that there are a lot of smaller operators who, short lines or even some passenger operations that just don't have the funds available to do this, and a lot of these efforts are not cheap. So I think that's one important takeaway I think that all groups had. Another one that I heard, that all 3 groups in some way, shape, or fashion mention is this idea of framing this approach through a series of goals, perhaps guidelines that may eventually lead to either standards or regulations. So, to focus folks in certain areas and certain approaches that we want to take, I think the danger is that if there's too much of a free rein, then there may be multiple systems that use widely different approaches to achieving this goal. That may lead to perhaps issues with compatibility down the road. If you have, say several different rail crossings along the same line that all have a different approach to doing this, to detecting traffic on the road crossings and different sensor systems, communication systems, and so on. So as we go on, some sort of initial set of guidelines, initial set of goals for this work would be really beneficial in trying to ensure that everybody sort of moves in the same direction as we go develop these systems. With Kutrick's role, same thing. It was we had some great ideas out there. I think Kutrick could definitely help to define some of these goals and approaches, to achieving these goals. And also, the communication piece of the business case piece, I should say, of defining what the benefits of implementing these systems would be, to drive some more interest in people saying, hey, this is why we're doing this. This is why we're spending the money. This is the benefit that we're going to get out of this. That may not be, initially very clear, for folks thinking, well, why are we spending all this money to deal with this problem at the grade crossing? So, it was great discussion. Appreciate it. And so now we'll move to the Q&A portion of the program. And as we spoke before, we prefer that anyone who had any questions here would post them in the meeting chat. That way, it's accessible to everyone. The Q&A function, unfortunately, is not as accessible. So if anyone has any questions, please post them in the chat, and we'll read them off and we'll address them to our panelists. So while folks are thinking of questions to ask, I'm going to start the discussion a little bit by asking our panelists, and I'll ask, let's say, Marco first and then David next. What would be the biggest technological challenges to the implementation of these autonomous rail crossing systems? So Marco, why don't you go first?
Yeah, I'm personally less concerned about the technology because we have, I think, quite a good experience with those these days in various environments, both from the rail industry and from the automotive industry. I'm more concerned about the implementation of those in real systems, and this maybe is as well a combined answer of Kutrick's role there in such a project, because Kutrick is great and leading these projects. Maybe Kutrick can look back as well on the successful projects and less successful, and I believe less successful might have been when we were lacking safety consideration, right from the beginning on, because we have taken technologies, put them into a project, put them into a live demonstration, worked fine, that's good. But then later on, when we come into real world of implementation with certification or authorization, I think we are lacking fundamentals of safety consideration. In this case specifically, if we want to combine rail and the automotive, I think specific consideration has to be taken into account. And I'm glad that Brian is here from Ricardo, who serves both sides, having the experience from rail and automotive, can help right at the beginning to make a project successful then.
Great. Thanks for that, Marco. David, do you have anything to add?
Well, not really much to add, actually. I think my first thought when you asked the question was was definitely the safety topic. So I think you, Marco, really hit on it. By the way, I apologize. My camera decided to not work anymore. So I'm just my name at this point. I think I would say that, and I would agree, and sort of just to kind of dig in a little bit more, the safety aspect is from a technical point of view is probably the most challenging. The performance is really, the sensors are there. I think it's, for the most part, the processing. And as I was saying in the presentation, it's really about, because there's some lessons that can be, and some knowledge that can be transferred from automotive, as well as from other spaces like aviation, and even in space and that. But the standards are also different as well. So it's something that there's work to do for the standards to kind of come to the same level as the technology. I suppose that's one aspect of it. And the other aspect is that some of the higher safety integrity levels for some technologies might still be quite a long ways away, because you are looking at, especially if you have something that has to rely specifically on an artificial intelligence or something like that, that's still very much an open question as to how those can be certified. Nonetheless, I think there are quite a few use cases with the technology and with algorithms that are available and can be certified, that can be addressed. But I think from a technical point of view, the safety is the largest hurdle.
Yeah, thanks for the input. Yeah, I understand exactly what you're both talking about. I've currently working in the zero emissions field of putting zero emissions equipment on rail vehicles. We've got the same situation right now where the standards that govern some of this equipment just are not there yet. There are standards sometimes that are that come from the automotive industry or from industrial settings, factories, and so on and so forth. But not all of those are applicable to the rail environment, and so we find ourselves having to look at some of those standards that are available for those applications, and having to sort of work backwards to see what that intent was, what was the original scenario that they were trying to deal with, and apply that into the rail world, and then kind of come up with our own set of guidelines based on what that original safety argument or safety issue was. So it's definitely it takes the standards a while to catch up as you sort of go into this new area where you're applying technologies that have not been used in for this type of application before in a new environment. So yeah, definitely I agree with that. So let's see. I think we're pretty much getting towards the end of the program here. So if there are no other questions from the, there's one question here. From Marco, in the example of existing systems you showed where they lead by railway operator or the city of government, I'm curious about who is leading these changes. Oh, they are led. Yeah, they are led by railway operators, city government. I'm curious who's leading these changes. Sorry.
Yeah, most of the example I shown, they were actually led by the operators, often like within the authority of the city, or like a private operator. Like Rio Tinto is a private operator. Obviously, they were leading the change and they were implementing it and owning it. Obviously, as well, with the big support from the industry and from consultancy for the certification. Similar, the Rivium, in the Netherlands, Rotterdam, to get their project. It's a small suburb there, which wanted to have the system. It is run by an own separated operator there, who were then like hired towards the system. Finally, the example of Potsdam, which is only a demonstration, not like in service operation already. They supported it, so they were not like owning it. It was more the industry side. On its side, it was Siemens wanting to demonstrate the technology and the way how it can be operated up there. And the very last one, these with SNCF, it's as well, again, the operator, which is more like a government-owned entity then at the end.
Okay, thanks very much. Got another question in here in the chat. What is the current state of knowledge of cybersecurity and digital trust for safety critical V2I and I2V communication across multiple vendors and operators? I'll let maybe David take this one first.
Sure. I think I mentioned in the presentation the sort of, for critical applications, how we focus more often on the use of things like private 5G communication systems and so on. I think so. We in many of our systems we use a specific communication gateway technology that is part of the system that we build, and it's capable of working with a number of a broad variety of different communication technologies. With respect to the V2I, I2V, and so on, I don't, from our perspective, we tend to be, with CBTC systems, we tend to work more in the space of LTE type communication networks or 802.11, that sort of thing, that we've installed because of the fact that we need to be able to control and ensure that we have the security that we need. So it's unfortunate. It would have been great to have the PLA for our digital communication systems to answer this, because he has quite a bit of knowledge in that area. But I will say that we do. There's a lot more focus now on the private 5G, although we can work with cyber secured public networks. We lack, in order to support safety critical timing and so on, you really need to have a network where you can control the configuration of the network and really get guarantees about how long things are going to take and so on. So the cybersecurity is built on top. For private 5G, it's much easier. It's available for public 5G. But maybe I'll let Marco talk a little more about the V2I, I2V, which is another way of doing this kind of communication with level crossing, sort of point to point, as opposed to broadcasting it out to a back office and then to the train over a 5G network.
Yeah, David, you covered the point. I mean, it's from traditional point of view with the CBTC system, we have really own network solution there that are like not connected to either the internet or any other communication ways in order to have a very high secure system. And elements like a camera, if a camera fails, like David's example here on the Zoom meeting, at least in real terminology, we would have to detect that it fails and that we can react to something there. And this is basic principles as well on the risk analysis on cybersecurity. It's not only the simple communication there that is a threat for new ways of cyber attacks. It can be simple as well that, a human person takes a USB sticks and connects it somewhere to a central control and do some damage to the system. So I guess what I want to say, it's not only about the safe or secure communication system there. It's about the overall control and how can we ensure that it is a safe system, at least for the critical mission critical elements of those systems there. I believe it is possible in some ways, but I want to like to look at as well what is simple ways of doing so and what are cost efficiency ways of doing so, rather than take any new technology that is out there that might be easy. but at the end, if something fails, it is way more costly. And these kind of, business case consideration, I think, are very important when putting new technologies into place.
Okay, thank you both very much. Don't see any new questions in the chat, so I will thank you both once again and turn it over to Morgan.
Yeah, we do have one. We are running up on time here, but I'm noticing one from a bit earlier. One last question. Maybe we can have a quick response to it before we pass it back to Vince to close out the session. But the question does go, as something on my wish list for a researcher who knows rail and academia, how can QTRIC and agencies help funding our research projects to help solve the problem of discussion? A long-lasting question for us in academia. Thanks for your accommodation. I don't know if we want to, Marcin, Marco, or David have a comment on that, or Vince, by that matter.
And I can comment because that's part of my role, but I'll defer to the speakers first. If anyone has comments.
No, I was going to perhaps bring up the work that we did in the past, Vince, which is really, trying to put together an innovation hub on this topic, right? That would be able to coordinate those types of activities. I think that's where I was going to go, but Vince, you're probably better to speak on that topic than I am.
The industry can bring in support and experience and knowledge, typically as well with younger generation there. But I think the organizational element will be within QTRIC, and probably you can answer, Vince, on this one much better.
And I will, but Marcin, when you throw it over, I'll just put my 2 cents worth.
Okay, yeah, I also have a little bit of experience with this in the U.S. I've helped a few grant applications over the last few years, in the field of zero emissions, and I know some of the folks at the federal agencies, the funding agencies, who are in a position to decide where all this funding goes. And really, the important piece there is they tell me is to have a solid group of partners when proposing some sort of an investigation, a pilot project or whatever, because when they look at these applications, they're really looking for who is ready to spend the money in a positive way. So if the application is sort of poorly written and you don't have folks on the team who would be able to actually do the work and integrate all these systems and components, in a way they'll provide meaningful results, then the likelihood of getting funding is low. So I would say, really, to get funding, you need to build first and foremost a solid team of partners who are all able to contribute and help you deliver on the project that you're trying to get funded.
Perfect. So if you want to wrap up, Marcin, then I'll take over.
Sure. Well, yeah, I appreciate, first of all, a big thank you to our speakers who, both had fantastic presentations today. Really great participation from everyone who joined. I appreciate it. Again, once again, everyone who joined us today here in the middle of your day to listen to these presentations. Had some great interaction in the meeting rooms as well in the chat rooms. So thank you for making this a very beneficial program with your interactions with the speakers, with their input and presentations and the interactions we had with all the folks who participated. And thanks once again to QTRIC for putting this together. And with that, I'll turn it over to Vince.
Thank you. And then I'd like to thank you, Marcin, for being a great moderator, co-host, sidekick, whatever, or lead. And Marco and David for joining us and providing us with that great little insight that gets people's brains thinking. Let me answer first the academic support question. So it is within QTRIC's mandate to seek and support academic institutions. We're membership-based organizations, so we have industry, transit, government, academia and consultancies and a number of other groups, including international engagements. In our membership fold, we have over 140 members, and we're trying to grow that. Part of my role, aside from leading this rail strategy initiative, is I'm the director of innovation initiatives, and that ties right into being in touch with the academics and the research organization. So it's in my domain. I will be reaching out with different organizations, different schools. We've done it in the past. Over the past summer, we ran an R&D innovation series celebrating projects that were done over the last few years. And our hope is that we'll be able to secure more innovation funding through the various government channels to do just that, to support research and develop HQPs in our sectors. So it's on our agenda that we do. But what I would like to say is part of that is the beauty of the consortium at QTRIC, other associations, is through active engagement and participation at events. That's how you meet certain people, and that's how you develop partnerships with industry players that have money, that are looking to develop the next best technology or prove the next proof of concept. So it's all part of the networking game. And so with that, I'd like to invite everyone to our rail conference, but more on that in a second. But first, I just wanted to talk about our next two sessions for the rail innovation strategy. Cybersecurity was asked. We have a cybersecurity topic, just like this topic, coming up. January 23rd is our expectation that date will happen. And then after that, we'll have another session on high frequency rail versus high speed rail policy focus in Canada. And that will cover our whole spectrum of our rail discussions, which will then be formulated into an overall topic, overall report that will go to government to advise government to say, this is what you should really be doing. This is what the industry has indicated, and this is what, the landscape is. So with that, if we go to the next slide, I would just like to introduce you to our rail conference, which will be happening on March 20th, 2024. It's a virtual conference, so we're expecting many international participants to engage with us as well. And it'll be a great way to meet some of the players, hear some nice topics, and help us move the needle forward. There's no sound.
Sorry, was there no sound?
No, we're having a technical difficulty.
Yeah, I think it's just a matter of sharing your screen with the sound on. Or it happens, works well in the practice session, but not on the main session. Thanks, Jenny.
Perfect. So in the chat, there's our link to the conference website. If you'd like to see our agenda, there's sponsorship opportunities. Speaker call is out there now. We've been inviting a number of people. So as I said, it will be a good number. We had one a couple of years ago. And we're the only organization in that I'm aware of in Canada that's doing the whole research and rail innovation side of it, as opposed to the regulatory side of it. But we will cover a bunch of that. So we look forward to seeing you there. So with that, I would like to call the meeting to close. And thank you all for participating, for giving us your input and insights. And we look forward to seeing you on January 23rd for our cybersecurity and rail operations in Canada. And with that, I'd like to close the meeting. Thank you all.
Thank you, everyone.
Thank you very much.